All right, everybody, let's get started. Thank you so much for being here. We are delighted to have you. We are very excited to share what we've been doing. We're really proud of the product. So with that, let's get started. So Prophecy is a low-code data engineering product. Before we get started, first, quick introductions. I'm Raj. That's Maciek. We are co-founders of Prophecy. A little bit of our backgrounds. I come from the world of compilers. I worked on Microsoft Visual Studio back in early 2000s when that was a great tool. And worked on CUDA. Thank you all for who use the GPUs for machine learning. Worked on the optimizer there. And then I came to the world of data. I was the product manager for Apache Hive at Hortonworks. And I apologize. I talked to a lot of customers, and they really struggled to use the product, use the Hadoop stack. And the takeaway was, all right, I'm going to spend the next 10 years building something that makes data engineering easy. So with that, Maciek, you want to introduce yourself?
Hey, everyone. Really happy to be here. My name is Maciek, one of the co-founders of Prophecy as well. Before this, I was working on many different data engineering and machine learning products. And probably, as a lot of you, I have experienced similar problems, right? I was trying to build my next generation AI models, but the low-level systems kept getting into my way. So with that, super excited to be here to show you what we've been working on at Prophecy and how we are helping with the data team's productivity.
All right. And then one bookkeeping item before we start. From our marketing team, you guys get Yodas for asking a question. These Yodas are extremely cute, will make you popular with whoever you gift it to. And then the next thing is there is a raffle for iPads. So if you all have tickets, at the end there's going to be a raffle. So get your iPads. The probability will be high. So all right. So with that, right, the first thing when we are like, OK, data engineering is really hard. How do we solve this, right? How are we going to fix this? So the first thing is, let's go talk to the data engineers and try to learn what their problem is. We spent lots and lots of time with you asking what the challenges are. So first, there's challenges for the producers who are building the data engineering pipelines. And then there are challenges for the consumers, right? The consumers is your machine learning team, your business analyst team that depend on data coming from data engineering. So what do the problems look like? First is, in data engineering, a lot of people got Spark or Databricks. One team uses it. You've got a few developers. And now, let's say you're an enterprise. You have, 7 line of business teams, and all of them don't know how to use Spark. Or they just want to get their work done. They're not so excited about technology, right? So there is that, right? But then you say, all right, I'm going to build a team. And then you go to hire data engineers. We are also hiring data engineers to help our customers. It is extremely hard, right? So you get some data engineers together, a couple of senior people, 4 or 5 junior people. You try to get them all to be productive, and they are not that productive. Data engineering pipelines are taking forever. Managers are not happy. Analytics team is shouting. So not fun. So what else, right? Even if you're doing your basic work, right? So let's say you've moved to code, you've moved to scripts, you're doing your basic work, and some of our customers, somebody also in the crowd is like, well, if I change a column, what happens? Who do I break downstream? And they have no way of knowing it. What are you going to look at? Your scripts and your Hive metastore? Right? So, or a value goes wrong, and then you are like, how was this computed? You wake somebody up, right? You're like, your pipeline produced the wrong value. And they're like, this pipeline is writing 1,200 columns. 900 of them are passed through. Wake the other person up. Right? So it's not like data engineering team has it together, right? Their life is not fun. But then the question comes is, what about their consumers? Who are you building pipelines for? Are they enabled? You ask a data analyst, they're like, yeah, I have this column. I don't know how it was produced. A lot of machine learning people are going to say, just give me the sources. I'll do the data engineering again. Right? So they're not happy. You ask metadata architects. They're like, I've got to track PII data, tens of thousands of data sets, right? And now they have to go sit with one team and another team, look at the Git repo, look at the Hive metastore, track PII. That is not fun, right? Or a lot of times the data analyst teams are not enabled, so they're waiting for data platform teams to build the pipeline, and they're stuck behind it. I could go on for a while. The basic thing is the state of data engineering, right? As we say, the state of union is strong, right? And in January, the president says. So it's like the state of data engineering sucks. Okay, so what do we do about it? So we said, let's say if you wanted to build a 10x better solution, very Silicon Valley lingo, right? It's like, what would it look like? So the first thing is, there's too much data engineering to be done. There's not enough data engineers. That is just not going to work. So you have to enable 10x more users to build data pipelines, right? So you have a massive pool to go with. And then you have to enable each one of them to be 10x more productive. Instead of 3 weeks, they've got to be able to build a pipeline in 2 days. And it's very doable, okay? So then the question is, all right, all of them are building pipeline, but what's the quality of the stuff they're building? Are the pipelines any good? It's like, yep, they can build, and we'll show you how. They can build pipelines which are extremely high quality. They are very standardized. So you're all kind of built out of the same Lego blocks. We call these gems, our visual components. So I'll go refer to them as gems in the rest of the call. So you build out of these standardized pipelines. You have the same set of high-performance components, and you connect them and quickly build a pipeline, and it's a good pipeline. And then you get a lot of reuse, right? So you get reuse. You've got a set of business rules. You reuse them. You use some standard terms. You get a lot of reuse from, let's say you're an insurance provider, and you're getting information from 10 different vendors, right? You want to, you change the data a little bit and then apply the same set of cleaning rules. You want to be able to reuse those. Can you reuse that in SQL? Hell no. There's no reusability, right? So then finally, it's like, your pipelines are good if you can look at them and know if it's distinguish good from not good, right? So you've got to have search, lineage, quality, so you can actually measure what you're doing, right? Now, so that's the next thing. And then comes the question of, we're like, okay, what else, right? A lot more people building really high quality data pipelines. What else would you want, right? This is your dream list. So then, like operational excellence. Our mission critical apps use Git, multiple branches, high coverage of tests, CI/CD, and all implemented imperfectly. But instead of pushing code every 6 months, we can push it every 4 hours. We want it to be continuous. It's not quite there yet, but it's way better. Now, don't you want to use those best practices for your data pipelines? How long does it take for you to move them from dev to production, right? You've got to move it fast, right? Or be able to revert them if there's a mistake. So this is what our customers, the first customers we worked with, our users told us, this is what we want out of our data engineering. We're like, okay, let's go build it. So, and then the next 3 slides are going to talk about a little bit about what we've built. So first is, where do you start? Right, so there is 2 different things that people have done for data engineering. On one side, you have the visual ETL tools. Right, the visual ETL tool says, you use drag and drop, you build a pipeline, pretty quick to build, standardized, you get business rules and other things, reuse, all that good stuff, and a few things come out of the box. You get search, you get lineage. So you get basic things that you want, right? It's batteries included. But there is a lot of challenges. Now you're locked into some company's proprietary format that's not going to work well over generations, right? And there is all this open source ecosystem, where all this innovation is happening. Amazon built a new DQ library. I happen to like it. That's a data quality library. I want to use it. No, you're stuck. You're in your own walled garden, right? So there are problems with this, and people have said, okay, let's all move to code. There is good things about code. It's 100% open source. A lot of people have, especially enterprises, in the last generation, they've been, paying enterprise companies through the nose, and they're like, I don't like that model, right? Once you're stuck, you're stuck. So they're like, what I want is 100% open source code, no lock-in. All right, we love that. Then is extensibility. Okay, you give me a visual tool, you have some things, but when I want to create a new component, you give me 20 operators, sources, targets, transforms, what if I want something more? Will I be stuck? It's like, no, data engineering today is a much wider field. I've got to be able to do anything I want to do. So that approach doesn't work, so you want infinite extensibility, and of course, like I said, the best engineering practices, Git, test, CI/CD. So Prophecy has, what we've done is we've said, let's combine the good points of both of these and build a product that gives you best of both worlds, everything you want. How do we do it? The first thing is, Prophecy has a mode with visual code turns into high-quality data pipelines. 100% open source, no lock-in. You can move to any Spark, right? Pipelines, it can be Scala, it can be PySpark. In about 6 months, we'll have SQL. So for us, it doesn't matter. We just add one programming language after the other. So now this code is really, really good. Because this code, we clean it up, it looks like the handwritten code of the best data engineers. So all your data engineers, especially the ones 1 year out of school that you just hired, the quality of pipelines they're creating is as good as your best data engineers. So that's the next thing is like you want high quality code, 100% open source, produced from the visual components. You're still using this simple visual drag and drop. If you have questions, yeah, go ahead. Or we could do it questions at the end. Could you wait? Yeah.
How does this interface, how does it integrate with the Databricks notebook?
Okay, so the question is, how does this integrate with Databricks Notebook? It does integrate with Databricks, not so much with Databricks Notebook. Now, what's going to happen is, I'm going to go through just 3 more slides, and then all the rest of the talk is Maciek actually showing you the product. So you're going to get to see the visual interface, the code, how it goes on Git. So, my talking part is very little, then we'll get to the real stuff, okay? And I'll get out of your way soon. And let's hold the questions to the end. It's just, we're going to go pretty quickly. If there's a short question, please, just like this, go ahead. If it's a longer one, we can take it later. Now, the next thing is, like we said, infinite extensibility. So what we've done, which is very different than all the other tools, is what we are selling is kind of the platform to build these visual gems. And you can build your own framework. You can say, this is how I do auditing. This is how I do data quality. So what your data platform team, the few Spark engineers you have who are really good at this stuff, they can build these frameworks and roll it out to all the other teams, right? So what this means is if you have your own sources, targets, a high-performance connector for Athena, you can create a new visual component out of that, right? Or you say, hey, this is our standard way to de-identify data, right? Remove the PII information. You create a high-quality component that does that. It goes into the menu of the product, and everybody gets it in the palette, right? So that means that everybody is using the same thing. So it drives standardization, and anything you can do in Spark, you can do here, right? So all you say is, here's my Spark function. These few things come from the UI, and this is how the UI is laid out. And even our internal inbuilt gems are created from this interface. So you're going to get autocomplete and get schemas and all that good stuff in your built gems. And then finally, standardization, we talked about this and reuse quite a bit. But there's things like you create data sets, you can publish, subscribe them. There was reuse because you can create your own visual gems, right? Your own data quality library, your auditing library, but also you can reuse subgraphs. So the reuse happens at different layers of abstraction. Often people have business rules engines, people who've worked in the last generation of products, and they're like, we use them across many places. So you get all of that. Now, whoa, sorry, that moved really fast. All right. So now the question is, now this is a summary slide. We're going to talk about now, if you look at our approach, the question is it actually better? Is it actually 10x better? Are you convinced? Let's compare it to the other approaches. So what are my choices? So first thing is, there's visual development and there's custom scripts. I have those 2 choices today. My visual ETL tools, yes, I get reuse. Many more people are enabled. They can be productive, standardized, but then, of course, you don't get any of that from the code, right? But what you want also is your pipeline to be in open source format. We just talked about that. Git, CI/CD, extensibility. You do that, you have to throw out these visual building tools. So you are in this world or that world, you cannot have the best of both. So what do people do? Prophecy is one approach. But as we talk to many, many companies, especially the larger ones, and the companies building technology, they build their own framework. They are like, this is code. I know, I want more reusability. I want some abstractions on top. It's not quite working from scratch. Let me build a framework. They'll build a JSON framework, an XML framework, right? Somebody will add a macro and say, the future of data engineering is macros. We said, let's not use it in C 30 years ago. let's go away from macros. But the future of data engineering is macros. So look at it, you're like, this doesn't make any sense, right? That's not the future of data engineering. So going back, right? So if you have visual tools, right? What are your choices? So you're going to use like the old generation tools. This is like an ab initio, a data stage, Alteryx. You're coming from any of these, going to the cloud. You're like, what am I going to use? Yeah, those are the choices. And even new tools like Matillion or Data Factory is just a copy of the same thing. It's just a visual tool, right? And then, and then I guess the macros is dbt. So, but we look at it and we say, hey, the low-code data engineering approach is actually the answer that solves this problem for real, which means that you get a lot of people enabled, those people productive, a lot of standardization, a lot of reuse, right? The abstraction that you actually want on top instead of your homegrown framework. And then, but without giving up any of the, any of the capabilities you get from the open source code. So with that, I'm going to pass it on to Maciek. We're going to do the demo. And what we are going to show you is how quickly we can get from one end to the other. We're going to start from Databricks with a partner connect, create a new account, create a new project, create a new pipeline, transform data. We are going to schedule that pipeline, commit it to Git, monitor it, and do all of that in the next few minutes. And then let's get to questions. With that, Maciek, all yours.
Cool, thank you. Yeah, this you can put here.
You don't need that.
Awesome. So as Raj said, yeah, we're going to try to build out this whole revenue pipeline, and we're going to do it all from scratch, right? So install the product, set up Git, develop it, schedule it, and observability on top of it. That's a lot of work to do. And we're just going to do all of that stuff in under 10 minutes. So we're going to start with Partner Connect. Now, we are a Databricks partner, right? So you can start directly from here. It's super easy. Prophecy is one of the tiles right on this interface, so you can just click on it and sign in, and you'll be done. Enter your password, enter your email, and you'll be directly taken into the Prophecy interface, all the integrations set up for you. Now, Prophecy is this complete data engineering environment. So we're going to start from here, and we're going to build out a pipeline that's going to allow us to compute the spending for every single customer per month. Now, we don't want to just build out the pipeline. We want to follow all the best software engineering practices. So on the other side, I have this GitHub repo already set up for me with some code that I can start integrating with Prophecy. I have my branches. There are some other collaborators here. Awesome. So I can just copy that and set it up directly in Prophecy. So we can create a new project. This is going to be my MRR reporting project. I can just enter the Git path right here, my email address. Token itself, I'm going to cheat a little bit. This project actually exists already, just to save 1 second. And there we go, right? So the project is set up, just took a few seconds, and all your code, branches, and all that good stuff that you've already had would be directly visible through this interface to you. So let's get started and build out that pipeline. We can just go ahead and create our customer spendings pipeline. And that opens up our visual low-code interface. So a few things to bear in mind here. On the top right, and I hope you guys can see it very well, there is my cluster connection box. So I can connect to an existing Databricks cluster or spin up a brand new one from scratch. Let's connect to an existing one. On the left top, I have all of my gems, right? So those are all the sources, transformations, targets, and I can add many, many more here as my team keeps evolving. At the bottom, you might see something very familiar to all the engineers in the room. So I have my branch. I have already some uncommitted files. As I kept working, Prophecy is doing already work for me. And I can switch between branches, commit my code, and all the stuff that the engineers are used to. So let's go ahead and build our pipeline. Our pipeline is going to ingest 2 data sources, run a join, and aggregate on it, and write it to a Delta table. Right? So I can just add a source gem to it, open it up. This is going to be my customer's data. So I can just say customer source. Now, Prophecy supports a bunch of different connectors out of the box. But the important thing to bear in mind is that it's very easy to add more of those connectors, because those are just Spark native connectors that already exist in the ecosystem. I'm going to use Delta. And for every single connector, we're going to show you the easiest way to essentially pick the file itself, right? So because I'm using a file-based connector, I just see a file browser here. If I would be using something like JDBC, I would see all my databases and tables. So let's just use the TPCH customers data. Oh. We can try that. Is this better? I don't know how is that going to affect everything, but sure. Perfect. So we can just look at the schema as well and see it loaded up. Nice. That just takes a second. And we have the preview of the data as well. So just like this, we have our first data source loaded up. And this is going to be my customer's data. So now let's just repeat this process super quick for my orders. Again, Delta file. Let's specify the location itself. And load up the schema. And all of those operations that I keep running are natively running on the Databricks cluster itself, right? So there is no black box magic happening in between. And there we go. This is our orders data. So I have my order key and all the prices for every single customer. Nice. So now that I have my data loaded up, let's actually start transforming it. So we can use one of the join components to join it together first. Just easy drag and drop. And once I open my transformation component, there's a few really important things to bear in mind. So for every single transform, on the left-hand side, we show you the schema. So you know immediately what you're working with. And once you start typing your expressions, we come in with all the best features that every single IDE should have, right? So we show you all the schema, all the columns, available with the types and all the functions with some helpful instructions. Now that my condition is done, I can also very easily pick all the right expressions. If I make any mistake at any single point in time, we have a static analysis system that's also running in the background. So all those problems you're going to be very quickly informed about, even before you start running your job. So let's just pick my price here and the date. Cool. Now we have our join running. So let's actually start running our pipeline, right? So I can click on play at any point in that pipeline to actually start running it and seeing the data available to me. I'm actually running here on a little bit bigger data set, so it's just going to take a second, but no problem. I can keep developing my pipeline. So I'm going to drag and drop my aggregate, connect it. Now, this was supposed to be a customer's report per month, right? So I'm going to group it by customer ID and every single month. There we go. And aggregate the summed prices. So this is going to be my amounts column that is summed. Perfect. Now that I have my aggregate ready, I'm almost done, and I can already see my data flowing through, right? So if I open up my customer source, this is pretty much the exactly same data that we saw. I see 750,000 rows, awesome, one partition, not so awesome, but I can also see the profile of the data available to me, right? I know that there is no nulls, and what is the skew of the data. Nice. So now my pipeline actually finished running as well, but I actually wish that it was running faster, right? This took quite a while to run. Normally, if I was following all the best practices, I would actually build a development data sample for this pipeline to run. But Prophecy comes with a lot of really good usability tricks that allow you to work with your data and code better. So what I can do is I can just very quickly limit the amount of input records that are coming in. And I can just say, I'd like to work with the first 10,000 records only, just for the purposes of faster development. So let's set that up, and let's spin it up. Let's see how fast it runs now. Nice. Now, this was snappy. Perfect. So I have my data now running quickly as well. Wonderful. And we can start writing it to a table. So let's look out at our report and how is it looking. And well, this is not looking very nice. I have here my month, which is a number. The amounts column is kind of weirdly formatted, and I just see my customer key with no other information. Not something I want to present to my CEO. So what I would like to do with it is actually clean up this data a little bit further. Well, what turns out happened is one of my coworkers have actually built already a reusable logic that I can now drag and drop into my pipeline. This reusable logic, what we call subgraph, essentially is already taking care of my customer cleanup and adding even some customer details. So now I can just drag and drop it, connect it. And let's run it, and let's see how my data looks right now. Yeah. Perfect. So now I have my data from the subgraph coming out, and wow, this is looking so much better. So now I have some demographic information for all of my customers. The month is actually readable, and my amount is prettily formatted. Exactly what I needed. Now this is looking better. We can start writing it to a delta table. If we want to see how this subgraph was developed, we can, of course, still open it up and see exactly what it's doing. It's actually a little bit messy, so maybe let's not deep dive it into it right now. But you get the picture. Every single one of your teammates can start producing reusable logic that now other people can be productive on. So let's very quickly just create a table and write our report to it. Now that's going to be a delta table. We're going to pick an existing database and create a brand new table for it. It's going to be a delta table. Let's make sure we overwrite it every single time. And there we go. Now our pipeline is ready. We can run it one last time just to make sure it's running. And here we go. So we've built our first pipeline. Awesome. It just took us 5 minutes. But this is not a one ad hoc report that we're building out, right? We would like to actually schedule it and run it in production. Prophecy supports 2 different schedulers, either Airflow or Databricks workflows. This is a simple pipeline, so we can just go with Databricks workflows. One click away, I can just schedule it directly. So let's type in our monthly report. We're going to run it on the first day of every single month at midnight. And let's make sure I get some good notifications every single time it succeeds or fails. Nice. So now the pipeline is built. We just have to enable it, and we're pretty much done, right? We have orchestrated, we have built out our pipeline, but there is one last step remaining. We actually want to release all of this code now to production, right? This would involve standard, CI/CD, best DevOps practices, but what you can do with Prophecy is there is this one-click button called Release that directly takes you to the Git, Prophecy Git Manager. Now on here, you can already start seeing that I have some uncommitted files. I have some other commits in the history. If you're familiar already with Git, you know how Git sometimes might be difficult to use, but we are trying to make it as easy as possible for everyone. So what I can do is I can just click commit, type in my actual commit message, new pipeline during the demo, and actually go through every single step in the commit flow, right? So pull all my new changes and finally merge my code to the prod branch. If I want to, I can, of course, create a PR directly from here and have it reviewed by an architect. But let's just keep going quickly for now. And now we're finally on the most important screen, which is the release itself, right? This is where my actual building, running the tests, and would happen, and actually finally deploying my pipeline to production. So Prophecy takes care of all of those CI/CD steps for you, but if you want to, you can integrate your own flow directly here as well. And so I'm going to just see every step by step. And of course, we can also look at the Git and how it looks like, right? So this was my development feature branch, and you can already see that I was pushing some changes 1 minute ago. If I open any one of my pipelines, you can see that just a minute ago, all your code was just pushed out as a standardized, neatly written code on Git. Right? Perfect. And our pipeline now is ready and released in production as well. Awesome. So we have built our pipeline, productionized it. It's all on Git, CI/CD setup. Well, there is one last question remaining, which is how do we make sure that this pipeline is actually now running reliably in production, right? And it's not failing or producing any wrong data. What we can do is directly on Prophecy, start seeing monitoring information on top of all your pipelines, data sets, and schedules. So I can click on the pipeline that we have created right now. We can see what data it's reading, what data it's writing, and I can click on the runs information. Right now on runs, every single run, doesn't matter if it's interactive or an actual production run, you'll be able to see directly here. So I can just click on those runs and directly see how many records were written, how many records were read, how much time did my pipeline take. As I kept developing this pipeline, I can actually see step by step how it was built out, right? So this was every single step that we were just running a second ago. And you can keep inspecting, monitoring, and checking how your pipelines are doing in production as well. Once you have maybe 2 different versions of code, this enables you to very easy benchmark your code as well. So this is the pipelines view, but you can also have the same information directly on top of your data sets. So once I open my pipelines, I can see all the data sets directly here, and the screen is a little bit zoomed out. Perfect. And now I can actually focus on those data sets, see the schema, how often were they read, what was the last time when they were read, and start comparing the profile of the data for them as well. So for every single run, I can see how many records were ingested or written to this data and compare them by every single run. Here's my profile, here's the data preview, and I can just keep scrolling for every single run. Perfect. Yeah, so just like this, we have completely built our revenue system, right? We have orchestrated, set up Git, CI/CD, developed our complete pipeline with a small layer of observability on top of that. Now, there is few more things that Prophecy is coming with that we don't have time to go through. So there is a gem builder, which allows you to very easily add any more of those gems. So if you have your specific use cases, very easy to build them out. There is unit testing. So once you start setting up your pipelines, you can actually ensure that they are running robustly and start building out unit tests for every single one of those gems. And there is also lineage, right? So it's very easy once you have a lot of those workflows built out to see how the code and how the transformations are changing the data as you keep going. Back to you, Raj.
One quick thing. Do you want to show the editor and toggle between visual
absolutely.
and code? We forgot to do that.
So yeah, if I open up the project itself, I can open up the pipeline. And so this was the visual view for the pipeline, but I can also switch out to the code view as well, right? So Prophecy is not supposed to be just the visual view. Everything behind the scenes, all the hard work that you're putting is turned into high-quality code. And this is something that all the engineers should be very familiar with. Those are my standard functions. Every single gem is turned into that function. And then those functions are ingesting and outputting your data frames directly while processing them within them. Cool. Well, I don't know how about you guys, but I really wish that I had a tool like this when I was building my data engineering pipelines.
And I think we started a couple of minutes late, so we can take questions now. And then just one other thing, like we want you to, have a great life, right? Don't spend late hours fixing your data pipelines. Just, spend a few hours, quickly build pipelines, go home, spend time with your family, play with your doggy, whatever makes you happy. So with that, questions. Can somebody help with mics? I think we've got first question there, yeah, Kishore, and yeah.
What's your pricing model like?
So our price is, I think it's $600 per user per month. So you can get us from Azure Data Store, Azure Marketplace, or from AWS, or you can just buy directly. And then, so it's like, so that's kind of the pricing model. It's per user because of productivity. And Kishore, make sure that person gets your data. I'm going to do 2 questions here in the middle. Or who else has the mic? Yeah, please.
If I created a custom gem, could I make that gem available to only a subset of users?
Yes. So basically what happens is when you create a custom gem, that's a project on Git as well. And when you create your project, you say, hey, I depend on these, and these gems. And so basically think of gems as a package. You can only use it for particular projects or for a particular set of users. So you can say this set of users get these gems, those set of users get that gem. So you will be able to manage that. Yeah, we have. So right now we are focused. It works really well on Databricks, right? But we also have other Prophecy enterprise. We have customers who are, using other Spark distributions in the cloud. We can work with multiple one of those. And we have on-premise customers. Some of our larger customers are enterprises who are on-premise, though we have a few of them. It runs on Cloudera or Hortonworks or even Spark on Kubernetes distribution. So we can work with each one of them. We are written as a Kubernetes operator. We also install within that, yeah.
Yeah.
Yes, can somebody direct? Yes, please.
So you have the visual code base to the underlying, you have that editor which goes to the underlying code base. So what if you make some changes to the code base? How does it translate back to the visual editor?
Sure. So what we did is we had a previous version of the product where the visual components were not generated. And in that case, you could go back to the other one. It's a roadmap item. We'll get back to it. We used to have it. So that means that if the code changes a little bit, we can parse it back. We've got a very strong compiler team. We'll just get back to it. When we move to this gem builder thing, we haven't gotten to it. So it's on the roadmap.
There's some people in the back as well raising their hands.
Yeah, we have 2 questions. One is, can you talk about the pricing model? So our price is, I think it's $600 per user per month. So you can get us from Azure Data Store, Azure Marketplace, or from AWS, or you can just buy directly. And then, so it's like, so basically think of gems as a package. Oh, yes. Okay. Can somebody from here, Shant, can you call? Yes, please.
Raj, how's your performance compared to custom code? Have you
Our
guys benchmarked
performance is at least as good as custom code. We've run it with multiple customers. It is as good. We are also, I think, Scott in Prophecy is working with the Databricks team to publish some metrics. It is as good. Typically, the performance is, there's no difference. If anything, our performance is going to be better.
Let's go to the back.
Okay, we'll go one back and one come back to you, Sai.
A quick question. So how the orchestration feature you just show connect to like external dependencies? Like especially for people who already have like Airflow and other DAGs or workflows?
Yes. So you can visually develop a pipeline in Airflow, and then we have dependency management. Maciek, you want to talk about dependency management?
Yeah, so one is dependency management, but another one is essentially all the Airflow operators that you have. Those are just visual gems that you can turn into the gems themselves, right? So if you have existing DAGs, you can just start dragging and dropping and adding them. And those DAGs, all of your code is standard code, right? With like a build system, POM, SBT, PyTools. So if you want to start adding dependencies into that, super easy and works out of the box.
Yeah, so you'll add dependency to that. We can pull dependencies from Maven and that, and then once you schedule it, it'll get deployed automatically. So all of that's taken care of for you. Yeah, I think we have got 2 questions up front that they've been raising hands for a while, and then I'll go, and there's 3 questions at the back right after. Huh? Okay, let's do one more question, then we'll be right here. Yeah.
Thanks. Any support for streaming out of the box?
Yeah, you can. The pipeline that you define can be batch or streaming. If you define it as streaming, you'll have the streaming operators will show up in your sources and targets. So Kafka will show up and those things. So streaming is supported out of the box.
And it's all native Spark, right? So continuous streaming, batch, micro batch streaming, all of that works.
All of that works.
Raj, can we do one in the back and then we'll do the...
Yeah, one in the back. Okay. One question in the back, please.
I was just curious, when you're like designing the pipeline and then how it generates code, if you discover that the code's wrong, can you manually edit or like override it, or will it get overridden by your design? Like, how does that work?
So code is not going to be wrong. We are doing static analysis of the code, and you have a code template that you are inserting values into. So, but I don't know if there's a better answer.
Yeah, when you're overwriting code, I'm guessing you're referring to the code that you're changing directly in Git, right?
Yeah, like how there's the toggle at the top.
Yeah.
Like if you
Absolutely, right?
discover
So
something
essentially
wrong.
what would happen is people write various code, right? You can write RDDs, you can write some dataset APIs in Spark. So we allow you to follow only the best practices, and we would start giving you warnings and errors if you're going out of that scope. But if you're sticking to the standardized code, right, you would be able to then visualize it back on the canvas itself. And this is the beta feature that essentially we're trying out with some customers.
So minor edits work. You can't just change the whole structure of the graph, but minor edits. I want to take one question here. I think this gentleman's been very patient. Yeah, we can hear you.
Quick question. So how do you maintain, like, when we are building this, data is passing through your system, how do you maintain, like, protect PII, or do you collect any data or any code?
So there's a couple of, so there's 2-3 different models, right? One is you can use Prophecy's public SaaS, in which we will have our best practices of encryption at motion at rest. The other thing is some larger customers can install this within their VPC. So if you go to Marketplace, you can just say, hey, install within my VPC. Then we don't see anything. Right? The entire software is within your VPC, your data stays within your VPC, and then similar with on-prem. I'm getting something from the back to say that's the last question. We are going to be right here, the raffle.